Hello everyone, welcome to part 3 of my video series on statistical significance testing. So in this video we are going to talk about Wilcoxon rank sum test, which is also known as the Mann-Whitney U test, and it is one of the most interesting significance testing that you are going to see and one of the most widely used in bioinformatics as well. So let's dive in. So first of all, let's look at an example. Suppose we collected number of people in 1000 Bangladeshi families and 1000 Chinese families. The question is, do Bangladeshi families have significantly larger or smaller number of people compared to Chinese families? It's a very simple question. It's a numbers game. And it's obviously two-sided test because we don't care whether it is larger or smaller. But after the video, you can also tune this approach for the one-sided test as well. It's up to you. So this can be our hypothesis, the null hypothesis, and the alternative hypothesis. The null hypothesis H0 is something like this. That means the two groups come from the same distribution. And the alternative hypothesis says that one group tends to have larger or smaller values. So let's now assume that, let's forget about 1000 families because that is just too much. Let's think about 3 families. So in Bangladeshi group, we have 3 families, group A, and their number of people are 5, 7, and 8. And in the China group, we also have 3 families, and their population is 1, 3, and 6. Okay, so what's the idea of the rank sum test? So it's about ranks. So the idea is we rank values of all of these values, of all of these things in these 2 groups, and we see how extreme are the ranks of each of these 2 groups. So if the ranks are extreme enough, then we reject the null hypothesis H0. So that's basically the name of the game, and we are gonna look at an example right now. So how do we get the ranks? So first of all, these are our values, and we have sorted them in ascending order. You can see that, and we have also written out the groups explicitly. So these 3 values are from group B, and these are from group A, and now we can rank them from 1 to 6. That is the ranking, and now we can get the rank sum. So RA, rank sum RA is going to be 3 plus 5 plus 6, as you can see right here, which is 14, and RB is going to be 7. So we are not doing anything but summing up the ranks here. That's it. That's all about rank sum. Okay, fine. Now here is a question, an interesting one. What is the lowest possible rank sum for a group containing n number of values? Understand this very carefully. You have a particular group. I mean, there are 2 groups here, obviously, there will be 2 groups. So suppose in group A you have n number of values in group A. So what is their lowest possible rank sum? Understand that if all of these n values of group A were to be smaller than even the smallest value of group B, that means all the n values of group A are smaller than group B, which is a very extreme case. In that case, these would be the rank values of group A, right? Starting from 1 to n, and from n plus 1, n plus 2, n plus 3, those would be the ranks of group B. So what is their sum? Their sum is 1 plus 2 plus 3 plus blah 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 n. And if you do the math, then this is what you are going to get from this. This is a finite series, basically, sum of finite series. So you can look this up if you want. So this is basically the lowest possible rank sum, right? Lowest possible rank sum of a group containing n number of values. So this is just a recap of what I just said. So this is the most extreme case when all values of this group are smaller than even the smallest value of the other group. Okay, so we are going to calculate these 2 statistics, UA and UB. UA is going to be the difference between the actual rank of group A and the smallest possible rank of group A. And similarly, UB is going to be the actual rank sum of group B minus the smallest possible rank sum of group B. So if we do the math, then UA is going to be 8 and UB is going to be 1. Now understand that we are going to calculate a U statistic. So U statistic is going to be the minimum of this UA and UB, which is going to be 1. Now here is where things get interesting. Understand that if all the values of group B were to be smaller than group A, then that would be the most extreme case, and in that case, this value would be 0. So the moral of the story is, the closer U is to 0, the more extreme the difference between the two groups are. So if U would be a fairly large number, that means some of the values of group A are big, some of them are small, some of them are medium, etc. So there isn't really significant difference between the two groups, group A and group B. But if we see that almost all the values of group A are actually much smaller than all the values of group B, then there is certainly a difference, right? And that difference can be sort of measured by the U statistic. And the closer it is to zero, the more extreme the difference of the ranks are. So how can we use this to get the p-value? That is the final touch. So I have covered this in detail in my previous lectures. So what is the significance of the p-value? And you know that normally we use a significance level of 0.05 for p-value. So let's see how do we get the p-value using this test. So in this example, we have total 6 ranks for the 6 values in the two groups. So this is just for this example. Now, obviously, if we had like 1000 values per group, then there will be 2000 values combined in the two groups. And obviously, for the 2000 values, we could assign 2000 ranks in total, starting from 1 to 2000, right? Now, this is where things get interesting. In group A, so let's talk about group A. In group A, there are 3 values, right? There are 3 values, and you have total 6 ranks. Very important to understand. You have 6 ranks and you have 3 values in group A. Now there are 3 possible ways of assigning the 6 ranks to the 3 values in group A. So let me show you an example. So maybe the 3 values of A are ranked as 1, 2, 3, or maybe 1, 2, 4, or maybe 1, 2, 5, and so on and so forth. And there can be 20 such possible ways of ranking the A values. Okay, that's the thing. So what is so special about this? The interesting thing is for each possible ranking, you can actually get a U statistic like we derived in the previous slide, right? So you see that only one out of all these 20 cases, you are going to get U equal to 1. That means the probability of getting U equal to 1 is nothing but 1 over 20, which is 0.05, which is extremely small. And so you can reject the null hypothesis. That means Bangladeshi families indeed have a larger or smaller number of people compared to Chinese families, right? That is the conclusion. So this is the way we do this. We calculate this p-value when there are not many values in the groups. But if you have a lot of values in the two groups, then this becomes very infeasible because then it is very hard to calculate all those U values. So in that case, you have a way around. So what is that? That is basically you approximate a normal distribution. You calculate the expected mean and variance of the ranks. And based on the normal distribution, you sort of get the p-value using the U mean and variance. Now, obviously, if you don't know about the z-test and the normal distribution, this is a bit hard for you to understand. But I will cover this z-test in later part of the series, so you can check that out. But if you do have some idea about z-test, then you know what I'm talking about here. And I think it should give you some idea about how we deal with the cases where we have a lot of values. So that's all about Mann-Whitney U test or Wilcoxon rank sum test. So in the next video, I'm going to talk about the signed rank test. The signed rank test, which is used for paired cases. So hopefully, if you like the video, feel free to subscribe and share. And you can donate to our channel via the link and the number in the description. Well, thanks very much.